Hello everyone, I welcome you to this video. Square root of minus 1, the value is equal to I. I is imaginary number. This we have seen in our earlier video. Today in this video we are going to see about power of I. This is a part of math lecture series, a video by See Through Maths. Powers of imaginary unit I. If imaginary unit I, this is having power 0 or 1 or 2 of integers. So what will be the value? So that we are going to see in this lecture. So I power 0. So we already know about this one. Anything power 0 other than 0 power 0, anything power 0 is 1. Second one, I power 1. So I power 1 is same as I. I power 2. What is I power 2? So I is equal to square root of minus 1. So square root of minus 1 whole power 2 is equal to minus 1. The next one is I power 3. So already we know the value for I power 2. So I write this one as I power 2 multiplication I power 1. It is I. So this is equal to I power 2 is minus 1 and I power 1 is I itself. So it is equal to minus I. In the same way, what is the value for I power 4? So it is nothing but I power 2 multiplication I power 2. I write in this way so that it is easy to calculate. So it is minus 1 multiplication minus 1. The answer is plus 1. If you see the answers, now the values are repeating. So I power 0 and I power 4 are same. The same way I power 1 and the next one I power 5. These two are same, equal to I. So I power 6 is same as I power 2. It is nothing but minus 1. I power 7, I power 4 multiplication I power 3 is equal to I power 4 value is 1 multiplication I power 3 is minus I. So this is equal to minus I. Okay. So this is the way how to find I power an integer number. If the numbers are small, it is okay. If the numbers are big, how to find the values? If you see here, only 4 different values are there. 1, I, minus 1, minus I. Okay, after then it starts to repeat 1, I, minus 1, minus I. So, if you look at this one, here 0, the power is 0, here the power is 1, the power is 2 and the power is 3. That means mod 4. If we divide a number, if we divide an integer by 4, we get remainder. Based upon the remainder, we get 4 different answers. Okay. So, here I power 8. If we divide 8 by 4, the remainder is 0. Because 8 is divisible by 4. So, the remainder is 0. So, I can put this is I power 0. The value for I power 0 is 1. This is the way we can easily calculate for higher powers of I. We can see some more examples for larger powers of I. The first one is I power 36. So here we want to see the number 36. If we divide 36 by 4, in my earlier lecture I have explained how to check a number is divisible by 4 or not. If we divide any integer by 4, the remainder may be 0 or 1 or 2 or 3. So here 36 is divisible by 4. So it is nothing but I power 0 equal to 1. The next one is, see, it's a little bit large number. I power 642. But whatever may be the big number, to check whether a number is divisible by 4 or not, we take only the last 2 digits. Okay, so here it is just 42. Whether 42 is divisible by 4? No. But if I subtract 2 from this one, or if I add 2 to this one, whatever it may be, that means I power 642 it can be written as 640 plus 2. That means the 640 is divisible by 4, so it is equal to this. I will write I power 640 multiplication I power 2. Since I power 640 is divisible by 4, this is equal to I power 0. That means I power 0, I power 640 is I power 0 into I power 2. So now whenever I see I power 0, I will not write again. It is 1. I power 2 is minus 1. The value of I power 642 is minus 1. Third one, I power minus 536. The same logic here. 36 is the last number. So 9 into 4, 36. So this is divisible by 4. This number is divisible by 4. Since it is divisible by 4, it is I power 0. It is equal to 1. Now we see some more problems in finding the powers of I. Simplify the following. The first one, I power 9. So first I will check power is divisible by 4 or not. It is not divisible because it is an odd number. So what I can do, I can write this one as I power 8 into I power 1. This is equal to, so I power 8, why I am writing I power 8? 8 is divisible by 4. That means this value is 1. No need to mention here again. So this answer is equal to I. The second one, I power 2022. It's a big number, but whatever may be the number is big. We are going to divide only the last 2 digits by 4. So this is even number which is not divisible by 4. Definitely remainder is 2. This is equal to minus 1. Next one. Now 2 numbers with addition. The idea is same. I power 1947. So how I can write this one? I power 1944. I know that 1944. 44 is divisible by 4 plus 3 plus I power 1950 is there. That means this can be written as 1948. See, after 44, 48 is divisible by 4. So plus 2. This can be written as this is equal to, see here, I power 1944. This value you can completely ignore. That means I power 3 plus I power 2. This is equal to I power 3 value is minus I. And this value is plus I power 2 is minus 1. This is equal to minus I minus 1. The next one, I power 1948 minus I power 1869. These are just random numbers, some big numbers for practicing. So 1948, see, just now we have seen 1948 is divisible by 4 by taking the last 2 digits of 48. When I divide by 4, I will get remainder 0. So this value I power 1948 is same as I power 0. I power 0 is 1. No need to write in step by step. Minus I power, this how can I write? See here 69 is an odd number. So remainder may be 1 or maybe 3. Okay, so if I subtract one number, it is 68. Okay, so I power 1868 is divisible by, this 1868 is divisible by 4. Multiplication I power 1. So this is equal to 1 minus I power 1868. This number I can take it as 1 into I power 1. I power 1 is I. So the answer is 1 minus I. That's all. We will do few more different types of problems. Yes, here this is really a testing one. Summation n equal to 1 to 12 I power n. So first I will substitute the values. What will I get? I will get, when I put n equal to 1, I will get I power 1, then plus I power 2, plus I power 3, plus I power 4, plus I power 5, plus I power 6, and so on. Plus the last term is I power 12. So what we can do, we have already studied one thing. So I power 1 is I, plus I power 2 value is minus 1, then I power 3 is minus I, then I power 4. This is equal to plus 1. So if we club everything into 4 terms, what we will get? See, I and minus I cancel. Minus 1 and plus 1 cancel. So if we take continuous 4 terms, the values are zeros. So this answer is 0. This answer is 0. And here it is I power 12. So this also comes under one club. You can see easily from here. The fourth term of this one is power 4, a multiplication of 4. The next one here it will be I power 8, then I power 12. So the answer is 0. So we did not have calculated what is I power 5. We did not have calculated what is I power 6. Without calculating these powers, we can able to find in simple technique. The next question, I power 59 plus 1 by I power 59. For this one, even though there are many different types how to find, either you take LCM here or find the value for I power 59, there are so many techniques are there. Anything we can follow. So I will take this one, I power 59. This can be written as I power 56 plus 3 plus, I will keep this one as it is, because what number I will get here, the same number comes in denominator here, the number and its reciprocal. So this is equal to I power 56. 56 is divisible by 4. So again ignore 56. So it is I power 3 only. I power 3 is minus I. So this is plus 1 divided by minus I. So I is in the denominator. I want to take it to numerator, or I want to take LCM. Even if I take LCM here, in denominator I will get another I. So what I will do now, multiply and divide by I here, so that I power 2 will become minus 1. Okay, so here there is a minus also. So we want to do it carefully. Minus I plus 1 into I is I divided by this minus is minus. I into I is I power 2. I power 2 is minus 1. So I put here minus 1. This is equal to minus I. Minus into minus becomes plus. So it is plus I. This is equal to 0. The value of I power 59 plus 1 by I power 59 is 0. Next one. Earlier we have seen about summation, but here it is product. I multiplication I power 2, multiplication I power 3, and so on up to I power 2000. This is a geometric progression. This can be written as I power 1 plus 2 plus 3 plus etc. up to 2000. This is equal to I power, so we already know summation up to n terms, it is n into n plus 1 divided by 2. That means here 2000 multiplication 2001 divided by 2. So first we will simplify this one, 2 and here 1000. So this is equal to, now you can see here this number power is 1000 multiplication 2001. 1000 is divisible by 4. That means the entire number is divisible by 4. So it is nothing but I power 0 equal to 1. Such a long term, but we have done a simplification in a very simple way. Next again a summation. Summation n equal to 0 to 10. I power n plus 50. That means this again I will substitute the value. So it is I power, the first number is 1. So it is 51 plus I power 52 plus I power 53 plus etc. up to I power 60. The same logic, I club this one into 4 terms. There are 10 terms here. So I will club it as 4 plus 4 plus 2. First 4 terms value 0. Second 4 terms value 0. So I will take only the last 2 terms. This is equal to I power 60 is the last term. I want last 2 terms. So the before term is plus I power 59. This is equal to I power 59 can be written as 56 plus 3. So I power 3 plus I power 60 is I power 0 because 60 is divisible by 4. This is equal to I power 56 is I power 0. Leave it. Here I power 3 is minus I plus I power 0 is 1. That's all. So this is the way how to find I power n, where n is an integer. That integer may be 0 or negative numbers or positive numbers. Now it's time to think, what is I power n if n is a rational number? So already we have seen for integers, other than integers, if it is a rational number like 3 by 2, 1 by 7, how to find? Next one, if the value of n is an irrational number, is there any value for I power irrational number? Or if the power itself is a complex number, what is the physical thing about that one? So these are the points to think. If you know the answer, you can leave a comment. Thank you.